The idea to build an outpost on the moon came up again and again over many decades, ever since we've been doing space travel. But would it really make sense? And what are the challenges? In 1920, Tsiolkovsky had already suggested this idea, and Hermann Oberth wrote about it in his books The Rocket into Interplanetary Space, 1923. This celebrates its 100th anniversary this year, and Ways to Spaceflight, 1929. In addition, Arthur C. Clarke wrote about a moon base in his short story The Sentinel, 1951, and in his book A Fall of Moon Dust, 1961. He even speculated about moon igloos, advising that they should be covered with moon dust to protect them from radiation. In the year 1992, NASA presented its detailed study, First Lunar Outpost, FLO, to the public. Yet it is only in this decade that we have the vision and the technical and financial means to do so. Thanks to private space companies like SpaceX, whose Starship HLS has been selected by NASA for the Artemis program to take humans to the Earth satellite starting in 2024-2025. No other body in our solar system received such an early visit from Earth. It was the Soviet lunar probe, Luna 2, that became the first artificial object on another celestial body in 1959, after the first probe missed the Moon by roughly 6,000 kilometers. Although it was an impact probe with 5 different instruments on board that measured the strength of the lunar magnetic field during the approach, among other things. Numerous probes and 12 astronauts followed over the years. Most recently, the Indian probe Chandrayaan-3 landed on it, carrying a lander and the rover Pragyan, which discovered sulfur on the surface near the lunar south pole and recorded a moonquake. Before that, the Chinese probes Chang'e 3 and the rover Yutu landed on the Moon in December 2013, along with Chang'e 4 in January 2019. It was discovered that the Chinese landing sites on the Moon had a surprisingly large number of different rock layers that differed from the Apollo landing sites. Accordingly, the geological history of the Moon may have been more complex and diverse than previously thought. The design of the lunar station will be strongly influenced by the cargo volume of the launch vehicle. It's possible that this will contain inflatable elements or even consist of unused fuel tanks. The more one can reuse and rely on lunar raw materials, and the less additional material has to be brought from Earth to the Moon, the more economical the construction of a lunar station would be. Because, let's face it, building a lunar base is a costly endeavor. There is only 1/6 of the Earth's gravity on the Moon, and we do not yet know how this affects the human species over a longer period of time. Thanks to this low gravity, however, it would be much easier to launch a rocket or a mass driver from the lunar surface. The Moon is only 385,000 kilometers away from Earth. Thus, there would be only a slight delay in communication with Earth. Currently, a sick astronaut can be evacuated relatively quickly from the ISS, whereas it takes at least 2 to 3 days from the lunar surface. Because of this, surgical robots remotely controlled by specialists will be used, and the entire medical facility would be a challenge as drug deliveries would have to be planned in advance. At the Apollo program, lunar landings took place near the lunar equator because it was easier to reach with rockets. But for a permanent lunar base, the Moon's poles would be more suitable. Day and night changes are not uniform on the Moon, but it depends on where you are. At the Moon's south pole, there is permanent solar radiation, and solar panels placed here could power a lunar base. While at the lunar equator, there is a day-night change around every 14 days. For the astronauts, this means there would have to be an artificial 24-hour rhythm so they would not suffer from jet lag. This causes a peculiarity on the Moon because it creates enormous temperature differences at different places, possibly leading to moonquakes. Unlike on Earth, these do not last seconds but several minutes. The entire equipment and the lunar station would therefore have to have a reinforced structure and be able to withstand large temperature differences. Oxygen-containing rock is another factor, since oxygen is needed not only for breathing but also as rocket fuel. Hubble used its UV cameras to search for ilmenite, which is composed of oxygen, iron, and titanium. Ilmenite can be used to produce water under high heat, as well as hydrogen. Using the R-oxygen system, the oxygen could be extracted from the lunar soil. Similar to the ISS, you'd get sunburnt on the Moon within a few minutes, but the ISS is still protected against space radiation by the Earth's magnetic field. Without a protective magnetic field, solar flares pose a serious danger to astronauts on the surface of the Moon who would be directly hit. For the Apollo astronauts, this was not a major problem because of the brevity of the missions on the lunar surface, especially since the Sun was closely monitored during the missions. But astronauts living and working permanently on the Moon must be protected against this. In addition, heavy ions would produce secondary radiation. Food in greenhouses would also be affected, and the faster a cell system divides, the more sensitive it is to radiation. So there would have to be a shelter for strong solar flares, or artificial magnetic fields would have to protect the station from harmful radiation over a large area. Another problem for a moon base would be micrometeorites. Without an atmosphere, these would not decelerate and will impact at very high velocities. For the shuttle program, an outer skin of aramid fibers was developed to protect against micrometeorites. But something has to be devised to withstand a long-term bombardment. An advantage could be an underground moon base. This would offer natural protection against cosmic radiation, micrometeorites, and solar flares. Due to past volcanic activity on the Moon, lava caves still exist today. In recent years, several of these black holes have been discovered on the Moon. These were formed either by underground lava tunnels or by surface lava flows. One of these holes in the Marius Hills area on the Earth-facing side has a diameter of 65 meters with a depth of 88 meters and was discovered by the Japanese lunar probe Kaguya. Another danger is the lunar dust that has already settled during the Apollo missions. The surface of the Moon consists of regolith, an ultra-fine dust that's the remains of meteorites that have hit the Moon. This dust is very sharp-edged and could damage humans in the long term if inhaled, causing pneumoconiosis. In addition, this can damage the seals and electronics of the lunar station, especially for rocket launches nearby, kicking up large amounts of dust. One solution to this problem could be spacesuits placed on the station's outer wall, preventing lunar dust from getting inside. This is a key technology for longer lunar stays, and unlike the Apollo missions, where astronauts spent only a few hours or days on the lunar surface, they would have to be usable for the long term. Therefore, comfort is also important and should not be as stiff and uncomfortable as previous versions. Initially, there will only be a research station on the Moon. However, the Moon would also be interesting for tourists, and as the next video shows, there are economic interests, which is why the construction of a lunar colony would be worthwhile. Thank you for your attention. If you like this video, check out our other videos about the future of space exploration.